Okay. Starting. So I think we can start, right? So basically today we have 3 hours, and we will first talk in the first hour and a half, more or less, what is written, contained in this set of slides. So objects and function, and then we will program a little bit together, okay? Experimenting with JavaScript, sorry, and experimenting with arrays and strings, okay? Okay, so in case there are any questions about what we've seen on Monday or in previous lectures, just ask. Otherwise, I will proceed. Okay. So first objects and then functions with the consequences. Okay, that come into play in JavaScript, because functions are quite peculiar in JavaScript, and we will spend a lot of time on functions because they're really fundamental element of the language. So first, objects. Well, objects are peculiar too, but I mean, you're probably familiar with the Python objects, so they're more or less similar. Okay. The only thing that you need to remember about object is that they may exist without classes. So they are not objects in the traditional sense of object programming languages, where you define a template that is basically the class, and then you have instances of the class, which are the actual objects that we call instances indeed. Here, objects exist regardless of the fact there is a definition of the object. Okay? You define it when you create it, and when you create the instance and not the template, so the class. Okay? So typically objects are created directly. There's no class. And objects also are dynamic. It means that what is contained in an object can change over time. So you can have methods and properties that are created while you are executing the program, or are also removed. Okay? So you may add, delete, and redefine, even redefine, because they are basically variables. Okay? A property or a method. Okay? And also in JavaScript there is no access control method, so it means everything is public. Everything can be accessed by any part of your code. Okay, this is quite peculiar of JavaScript. And remember, always remember where JavaScript comes from. Okay, it was designed in 10 days for a specific purpose, and add a little bit of code to some web pages, and then it evolved in a very big programming language. And so, some decisions were taken without thinking too much about them. Okay. And also, there is no real difference between properties and methods because of how JavaScript functions work. Because JavaScript functions are basically just objects, so it can be assigned and used, as we will see later today, as normal values. Okay, so they can be contained in variables, and in this case in properties of objects. So an object, what's an object? It's an unordered collection of properties. So it's not an array that is ordered, that has keys, typically numbers, but it's an unordered collection of properties. Each property has a name that we call key. Okay, so the name that we use to access the property, to refer to the property, and then also a value. And of course you use the property name to retrieve property values. So let's see a simple object, a point, x equal to 2 and y equal to 5. Okay, there are two properties. The name is x and y, and the value is 2 and 5. Or we can have other kind of values. Remember last lecture we saw the values that we can have. So numbers, strings, booleans, null, and undefined. They are the primitive types. And then there are more complex types. That means arrays, objects, and functions. So here we have properties that store strings for the first three properties, and then a number for the fourth property. Nothing really special. Okay. Just beware of the syntax. I mean, I can define the properties using the quotes or without the quotes. Okay. The properties are strings, and the syntax of the language supports that you don't use quotations. Okay, as I would reasonably expect. So if you have a look at the Python tutor, I hope you try the Python tutor at least once between, from last lecture. You see this representation. So basically, there's something in the memory which is allocated by JavaScript, and there's a place where there is the key and the value stored. Okay, more or less like with the arrays. So property names are strings, of course must be unique, because they are the way in which you access properties. You cannot define two properties with the same name. Okay, the second one will redefine the value of the first one, so like with variables. They can be created at object initialization, but also added after the object creation. Okay, and can also be deleted. There's an operator. Actually, this operation is not so common, but I mean, for completeness, we cite it. And the property values can be anything, any value which is a valid value in JavaScript. Okay, so any JavaScript value stored inside the object if they are primitive types, or if they are not primitive types, what is stored is the reference to the other complex type. That means object, functions, or arrays, and maybe also functions. Okay, and since with many object-oriented programming languages, we call functions inside objects methods. Sometimes we will call them methods, even if actually they are just variables which have a reference to a function, okay, as a value. Okay, good. We saw how to define. Let's see how to use it. Well, there's the dot notation or the square brackets notation. So as we see here. So we would like to use the author property of the object book.author. Very intuitive and very common also from other programming languages, right? But we can also use the square brackets notation. Just remember that you need to pass a string, okay, to put a string as an index. And of course, if the property name is quite peculiar, it means, for instance, it contains spaces or strange things, I mean, the only syntax that you can use is the square brackets, okay? But I encourage you not to explore this kind of weird behaviors of JavaScript and keep things simple. Programmers typically, when they need space, they put an underscore, so there's no problem in having a continuous string. Otherwise, it cannot be parsed by the JavaScript interpreter. Okay, so as you can see here, you see a first difference from the previous example. We have a property with name chapter space pages, which is an array. It means that in the memory there's an array which is created actually when the object is created, because it's defined right here. And what is stored in the object is actually the reference. That means the arrow here in the Python tutor representation. Okay. Okay, no. Yes. If you want to copy the value of chapter pages, okay, you access the book in the property chapter pages. You take the value, you can use it as any other value. Just remember that is a reference. So when you use it, you have the reference to the same object array, whatever, that is stored in what you're using, okay? So in this case, in the property of the object, okay? So you end up with num pages being a variable which has the same reference as chapter pages. So indeed, the arrow points to the same array. If I change something in this array, it will be reflected, so it can be read both from chapter pages and from num pages. Okay. So basically, we can see objects in JavaScript as what we typically call associative arrays. It means arrays where the index can be anything. I mean, can be a string and so on. So it means we associate a key, what we said before, key, which is actually the property name in this case, and a value. Deleting properties is easy. I mean, just for completeness, just delete with the name of the property, and the JavaScript interpreter will delete the property. Okay. Otherwise, we have no way to delete properties. I mean, we can just set it to, some values, undefined, null, whatever we want. Okay, creating object properties is a quite flexible mechanism. I want to mention this one because sometimes it will be useful in our code. Okay, so we can even specify the property name as a variable, which typically contains a string. Okay, so in this case, we define an object. In the simplest way to define an object, you already got it, is open a curly bracket, and then we decide to have a property name whose value, I mean the value of the name of the property, is what is contained in the variable prop. Okay, so open square brackets, prop, the colon, and then the value that we would like to assign. So basically, we can parameterize the way in which we create the names of the properties. Okay, because we can use also a variable, and we don't have to type a fixed string for the name of the property. And of course, in this case, the only way to create it is using the squared brackets. We can put any expression, but I invite you not to do it because the code is already sometimes difficult to read when we do these things. Okay. Yeah, just beware of the quotes. I mean, if I use the quotes, it means this is actually, the string is actually the name of the property. If I don't use the quotes with the square brackets, it means that a variable with this name must exist, and we search for the value, use it as a string that is the name of the property. Okay? But I mean, it should be quite easy to understand. Just beware of the fact that if you access a property which doesn't exist, JavaScript doesn't give you an error. It gives undefined. Okay? So there's an object, the object exists, but the property we are looking for doesn't exist. So like here, I mean, we write book.author. If author is not a property of book, this code doesn't throw an error, doesn't do any particular thing. It just gets executed. It gets a value undefined. Okay. Any variable which is not already, doesn't already contain a value in JavaScript is undefined. What you cannot do is, use undefined and search for a property on undefined. So, this is a quite typical programming pattern. You have an object that contains another object and so on. So you have dot and then another dot to access the second object. Well, of course, if the first property contains undefined, then you cannot access undefined with dot something. Okay. So the second thing here will give you an error if book author doesn't exist, so it's undefined. That's why typically when you access properties of object, you are not sure if they exist or not, maybe because the object has not been created by you or whatever. You typically check if the value is not undefined. Remember that undefined is one of the falsy values. So if we put it into an if, we can distinguish between the case undefined and not undefined. But just beware of the fact that the undefined is not the only falsy value. If you have a number, you need to be careful, because if 0 is a good number as a value, I mean, this system doesn't work, and you need to check explicitly for undefined with some other systems. And this leads us to this expression, which is quite commonly found in JavaScript. Now, I would like to access book author's surname, but I'm not sure if the surname property exists or not. So I should do these checks, two ifs, okay, two checks. But you know that maybe you already got that JavaScript doesn't like to be verbose, okay? But I mean, once you enter the way in which you should reason for JavaScript, it makes some sense, okay? And so you can have an expression like this, where you have the double and that basically is the same that you use in conditional expression, and checks if the left part of the expression evaluates as true, the value of the whole expression is the right part. Otherwise, it's the left part, okay? So in short, if books is undefined, the expression is undefined. The whole expression is undefined. If book is defined, it means it's an object and you have the book author property, and book author is the value that you get from this expression. And you can chain them. So basically, you can try to access a property deep into the tree of the objects without risking errors in this way. And it's a quite compact way of writing it. Okay. Of course, if the property doesn't exist, you will get undefined, and you have to deal with undefined afterwards in the code. Okay. But you don't risk that the program stops. Okay. So you have an error that stops the program. By the way, every time JavaScript has an error, it throws an exception, and typically you didn't catch the expression. It means that the execution of the program stops. It means that if we are using it on a server, the server crashes. And if you are using it in a page, in a client, in a browser, it stops execution. So it doesn't respond to further interactions and so on. So we should avoid at any cost the program crashes. But I would say it's quite typical for any programming language. We don't like programming to crash. Okay, how do we enumerate properties? Well, with the for in syntax. That's the only place where we are going to see the for in. Remember when we saw the control structures, we say for in. Okay, that's okay for properties of objects, but the only place where we use it. Otherwise, we use the for of for the arrays, for instance, and so on. Okay, so for in case we need to iterate over the properties of an object, it's okay for some reasons. And remember the fact that it gives us, you know, the name of the property, not the value. So the key, not the value. If we would like to have the value, well, you can do it with the square brackets. You get the value of the property, yeah, on this object, book. Okay. So you can try this code. I mean, we can just have a look. Let me try just once with the Python tutor. Okay, until now we use the Python tutor. Oh, I need to open. Let me see if it's connected. Yes. So the Python tutor. Just type it. Please remember always to use strict. Okay. That's the best thing you can do. And okay, book, and that's a structure that we were seeing before. Okay, on the right. And then we iterate over the properties in book, and there are three properties. Okay, author pages and chapter pages. And prop each time will get the key, okay, of the I mean the name of the property, so the key of that specific property. Okay, let's try it. So first time, no, okay, first time author, so prop, okay, gets the value author, and you use it, okay, to access book. So book prop will be Enrico. Okay, oops, sorry, press it last. Okay, will be Enrico. Okay, and we get console log with this template literal. You remember from last time, $, curly bracket, and there's an expression inside. Okay, fine. And then we go on. It gets pages, and we will access pages, and it gets chapter pages, and we will get the value of the array. Okay. Console log is quite a convenient function because when it gets a complex object like an array, typically it iterates over the array and it prints you the whole array. Okay. Okay. Just one thing I would like to mention. You might have noticed that we use the const. Okay, it's fine. It didn't give us an error. Okay, so that's because every time you iterate in the for, the variable is created again. Okay. So it's fine to have const, and in general we like to use const every time if it's possible in JavaScript, because if we don't expect that we should change a variable, if we use const, we run into an error when we try to change it, and so it's easier to debug. Okay, that's very simple idea. So unless we need really to change the content of a variable, define it as a const. Okay. Actually, we could have done const here as well. Okay. Well, I need to edit a bit. You can play a little bit, right? Because indeed we didn't change the value of book, right? Yeah. So just try. Okay. Okay. So if you have questions, please ask. Otherwise, we proceed. Yeah, there are methods. I mean, this is just for reference. I don't want it to go into so many details. I mean, when you need it, the important thing is it's that you know that there should be a method that returns something that helps you, and then you search for it. Okay. There are methods that give you keys and all the entries in the form of arrays. Okay. An array of arrays with just 2 elements, a key, a value, and so on. Copying objects. You remember copying arrays? We had to use array from, array of, or we need to use the spread. Okay. Copying objects. Well, the problem is the same. If you just assign the reference, you copied the reference. You didn't create a new object. Okay. Well, there are a few ways to do this, again, as with the arrays. One of the basic ways to do it is using a predefined method of the JavaScript library functions. So object is a predefined object, as arrays, as functions, as math, and so on. And object is a static method. I mean, I say static in the sense of object programming language, but I mean, you don't have to have an instance of an object. I mean, the object is already object. You can call .assign and pass a new object and a reference to an object, and this object will be duplicated inside the first object, which is actually empty. Open and close the curly bracket. Okay, so you end up with a copy. So how does object assign work? Well, object assign takes actually more than 2 parameters also, but at least 2 parameters. One is the target object and the other is the source object, and it copies the source into the target. So actually the target could also be not the empty object in case you want to merge objects, but I mean the very common use is having the empty object on the left and copying what you put on the right. Okay. Just be aware of the fact that if properties already exist, it will be overwritten. We cannot have 2 properties with the same name. Okay, it returns the target object. Okay, but yeah, it's convenient when you put the new object here, because otherwise you don't have the handle, you don't have the reference. Okay, otherwise you have the reference already. Just be aware that as with the arrays, we only make a shallow copy. It means we don't go deep into copying recursively all the values in objects, arrays, and so on. So in this example, you see that we have an object study, which is 2 properties, 1 string, and a reference to another object, book. Okay, so study, that's the object, and we have a reference to another object that is I mean something like okay, author Enrico, pages 340. And if you do object assign, you end up with a new JavaScript object. So above here, that's the previous situation, and below, that's the new situation. You end up with two objects with JavaScript and source. I mean, topic JavaScript and source. But you have only one of the object that is referenced. Okay? So in this case, if you want to duplicate everything, either you write your own code or you search for a library or library function, whatever, that does it for you. Okay? It goes recursively in the tree, and when it finds an array or an object and so on, and if it finds it, it duplicates it for you. Okay? So just be aware of this fact. I mean, we have references and we are copying references unless we do something explicitly. Merging properties, so always, again, object assign, target, the source, we call it source before, and we can have other sources, and basically they get copied in the first object, so in the target. And so in these ways, we can also define, let's say, default values. Again, we are showing programming patterns here that are convenient for purposes that we will show later in the course. Okay, so in case you have you would like to have a new object with some default values, and in case there's an object that has a value which is the same as the default one, you take the new value and not the default one, just with a single expression. Okay. Okay, so let's say there's a title which is the default value. Okay, in case we then have another object with the property title. Okay, so let's say new object, default value, but if book has a property title, it will be overwritten. If it has not, it will be created. So it's a sort of default value. Okay, I think it's quite intuitive. You should be able to try it yourself. Okay, nice thing. We have something similar to the arrays, which is called the spread operator here, the 3 dots, and we can use it as we did with the arrays. Okay, so book 3, that's a new object that takes all the properties of book 2. We open the curly bracket, it means it's a new object. And then what's inside? Exactly what is already inside book 2. Okay, as we did for the arrays, we open the square brackets. And it's very convenient way of writing things, and it works in the same way as the arrays. So you can also have partial properties. I mean the remaining properties in a single variable that will actually be a reference to a new object with only those properties. Okay, so here we have 4 properties. We would like to extract the first 2, and the remaining one will go to others. We can do it with just a simple way of writing it. Okay, we don't have to create a new object and just copy manually the first 2 properties and then create another one and iterate over the property except the first 2 ones and so on. Okay, this can be written very compactly. I mean, in a very small way with this syntax. Okay, why I write it here ES9? Well, I started last time saying that we are focusing on ES6, I mean the version of the JavaScript language. So some of the nice ways of writing expression in JavaScript are not ES6, but are from later versions, like this spread operator for objects. Okay, but I mean for our purposes we shouldn't care that much. I mean, I just pointed out in case, sometimes you will have to use, only ES6 syntax. So I would like to point out that this is not ES6 syntax. But, I mean, for our purposes, I mean, the environment Node.js support the latest version of JavaScript. So it supports the spread operator for objects. And also, when we will use React with a framework that will prepare the code for us and so on, it will take care of translating this syntax in older version if it's needed. Okay, so in short, we don't care. Okay, it's I mean, for us, we can use the latest version of JavaScript. That is fine for the purpose of this course. Okay, operator in, it works also outside the for, basically to check if a property exists. Okay, remember again, just properties. You cannot check if a value exists in an array with in, like you do in Python. Okay, here you cannot. It's just for properties. Okay, and well, how can we create objects? Just for completeness, there are library methods, functions. You know, it's the same in JavaScript. That allows you to create objects. Okay, you can say new object, or you can say object.create and pass an object. Okay, so this is a bit less useful. Okay, or you can use a constructor function that is the last topic. I mean, really the last slide of this set. Okay. So we will see it after functions. So a few words, I mean, not really a few. I mean, functions are really important in JavaScript. So a lot of words about functions. Okay, and that's the last big topic of the language. And then we can try to focus more on the programming patterns in JavaScript and so on. But functions are really important in JavaScript. So we need to understand them very well. They are one of the most important elements in JavaScript. They delimit a block of code with private scope. Okay? So, you know, in JavaScript, everything is public except what you put inside the scope of a function. So the functions is the only way in which you can make things private, okay, in a certain way. And we will see how. Well, functions, as any function, accept parameters and returns values. Actually, in JavaScript, they return just one value, okay? But it's not a so strong limitation because you can return anything. You can return an object, you can return an array, you can return a function, and so on. In an object, you can create properties, and so if you want to return two values, you create an object, you put two properties, and you return that object, okay? So the fact that you can return just one value in JavaScript is not a problem. In fact, that's because it can be an object. Functions themselves are objects in JavaScript. This means that they have a reference, and so they can be used as a value in any place where you can put a JavaScript value. Okay? And in particular, they can be assigned to a variable. And if we assign it to a property of an object, basically we created what we said before, a method. They can be passed as an argument to another function, and they can be returned from a function. Okay? And we will do all these three things always because JavaScript works this way. Okay? So they are another type, and we can use it, and we will use it a lot. So first, let's understand how functions work. First, how functions are defined. Very simple syntax. Function, that's a keyword, okay, like a for, switch, and so on. Function, you give a name, you open the rounded bracket, and you put a set of params. 0 params, 1 params, 2 params, and so on, okay, with a comma. And then you open the curly bracket and you write your code. And you do something, typically with the params, you return a value if you like, and so on. Okay? So they look more or less like C or Python. Okay? Well, Python doesn't use the curly braces, but it doesn't matter. So, very simple function, I mean, for a basic computer class. I mean, function square, parameter x, let y equal x times x, return y. I mean, we don't have types here. You remember that x can be anything. Of course, if I pass a string here, I mean, the function will not work, probably it will give you an error because you cannot make a string times string. But if you pass a number, the function will do the operation, will return a value. Okay? So let n equal to square 4, you will get 16. Okay? No problem. I mean, really easy to understand. You can try it with the Python tutor, but actually there's less to see with the Python tutor with functions. I mean, because functions are an object, and the object contains the code and nothing else. Okay, and then they are executed. So, I mean, the only thing we can see if we point to the same function or another function when we duplicate it in case. Okay, parameters. They are comma-separated list of parameter names. We can also assign a default value in case you need it. So function a, comma b equal to 1. So 1 is the default value for b in case b is not passed. Okay, and then there can be some code. Parameters are all passed by values, by value. Well, that's normal in JavaScript. Actually, there's no alternative, because if they are primitive values, we copy the values. If they are not primitive values, we copy the reference. Okay? So if we pass an array, we are passing actually the reference to the array. So the function can operate on the same array that we pass to the function. And we have in the code that is calling the function. So actually, parameters are copies of the value that we pass. Okay? If it's a primitive value, it's a copy. So string, number, or boolean. And if it's not a primitive value, it's a copy of the reference. So we can change it, but the original value or the original reference will not change in the caller function. Parameters that are not passed in the function get the value undefined. This is, you need to remember it very well. I mean, if we have a function that expects 2 parameters, we call it with 1, no errors. Just the second parameter will have the value undefined inside the function. Okay? So you need to be careful when you call a function. Okay? Because, I mean, if the signature of the function and of the place where you call the function doesn't match, there's no error. Okay? Just you have some undefined around. Okay? And actually, undefined is a value. So in case you need it in the function, you can check if the value is undefined. Okay? Not, I mean, not the triple equal and the undefined without the quotes. I mean, it's not a string. It's actually a JavaScript value. Okay? So let's say you have an optional parameter to the function. No problem. You declare the optional parameter, you call it without it, and you can check it inside the function if the value has been initialized or not. Okay? You can have variable number of parameters. Okay, since, I mean, there's no problem in having more parameters. The point is, how do I get access to the parameters passed to the function? Well, actually, this is the way. There's an operator which actually, again, the 3 dots, which in the function takes the name of rest instead of spread. Before it was spread, in the sense we spread the values over the array or object. Here we rest, I mean, we collect all the parameters into a single variable. That since there might be more than one, it will be just an array of the values. Okay? So we expect R to be an array, and in case we need to do something with this array, I mean, we need to iterate over the array, and it's an array, so we can use for of or other method that works with arrays. Okay, just remember not for in, but for of. Okay, so this function basically sums all the parameters which are passed, and it can be a variable number of parameters to the initial value, so sum initial value and sum plus equal a. So a is added to sum, okay, until we have parameters, and then we return the value. Okay. Other ways of declaring functions. Well, since functions are objects, so they are what we actually have is a reference to the object. We can simply assign it to a variable, and then use the variable with the rounded brackets to call the function. Okay, we don't really need to have. We don't really need to define the function in the code and use it by its name, but we can use it also through the reference. So we define a function even without a name. Okay? Of course, without a name, if we do it here without a name, we have no ways of calling it. But if we assign the function to a variable, the variable is the reference to a function, and with this fn, we will be able to call the function. Fn with a rounded bracket, and then we call it. You can also give a name here, but actually, that's not that much useful because you assign the reference to fn, and then you will use fn. Okay, so it's supported by the syntax, but not really so useful. Okay, and then there will be a fourth method, the last method. So you see square as we did before, and then we have cube as function c, and then we call cube. There's no difference between using a variable, which is a reference to a function, or actually the name of the function itself when defined into the code. For JavaScript, it's exactly the same. There's no actual difference. We can use both syntaxes, and for JavaScript, it's exactly the same. Okay? So in short, the expression function, etc., creates a new object of type function and returns the result that we assign to a variable, in this case, cube. Okay? We could also have written const cube, and so on. It doesn't really matter. If we don't think to reuse the variable, that's fine. So any variable may refer to a function, and any variable can be used to call it. We just open the rounded bracket, and that's all. We put the parameters, and the function will be called. So this function, so the reference to the function, can be put wherever you like, into an object, into an object property, but into slots into an array, and so on. If you put into an object property, basically we have a method, what we call in traditional object-oriented programming languages, method. Okay? So something on which you can open the brackets and call the function. Okay? You can pass it as a parameter to a function, and this is more peculiar, and in this case we typically call the function callback. But for JavaScript it's exactly the same, and this is just for us to understand. Okay? It's just a matter of naming for us, for users, not for JavaScript. For JavaScript it's exactly the same. It's a reference to a function. Okay, so third method, arrow function. That's a more compact syntax to define functions, which is what you see here. Instead of using the keyword function, we just use this symbol that is a sort of an arrow, which is actually the equal sign and the greater than sign together. Okay, so that looks like an arrow. And in this case, you cannot put a name. And so basically, if you need to use it, either you put it where you need to use it, or you assign it to a variable. So you have a reference to the function. Okay? So then you need to know how to write the parameters and how to write the rest of the code. Okay? So the parameters need to be written before the arrow, and then the rest of the code is written afterwards, after the curly bracket. Actually, since the arrow functions are so commonly used and so convenient, because you type this arrow, which is nice to read and so on, and they are so very much used throughout the JavaScript language, there will be even more compact forms of writing this function. But let's see an example first. Let's put the fourth power as a function written in the form of an arrow function. So we take parameter x again, arrow, and then the code is return square x times square x. Just an example. Okay. Now, of course, we can call it, and it will work as any other function. So, how do we specify parameters and return values in arrow functions? Well, the third row is what we already saw before. So we have parameters and we put them between rounded brackets. That's fine. This is mandatory when you have more than one parameter, because we have the comma, otherwise the parser will not be able to parse the code. Okay? So 2 parameters, it's mandatory. But if you have one single parameter, you can omit the parentheses, so the brackets. And you can also create arrow function without parameters. And in this case, you need to open and close the rounded brackets. And then you use the curly brackets for the code. That's fine. Okay. Okay, you can use default values, but I mean, this is really a small detail. The return value in functions is always undefined unless you return something. Okay, JavaScript likes undefined. Everything you don't specify is undefined. Okay, either the content of the variable or the return value of functions. But if you use the return keyword, you can return a value. But we already saw it. I mean, it was a bit implicit, right? Return square, square, and so on. Return y, etc. Okay, that's very common in programming languages. Have this return statement. Only one value can be returned. Anything can be returned. Arrow functions have an implicit return value if there is only one value computed inside the arrow function. Okay. So we can write the previous function fourth power as x without the brackets, because it's just one parameter, arrow, just the expression to be returned. Okay? But it needs to be 1. Okay? If you are doing more than one thing, you need to open the brackets. Okay? And then use the return statement. Okay? This is quite common, and it can be confusing sometimes, because maybe you write something more and you forget about the brackets, or you put the brackets. If you put the brackets here, this doesn't work anymore, because brackets square times square returns undefined, because the default value is undefined. So you need to put return that value. Okay? So be careful. It's not just we can simply add the brackets and it works. Okay? If you put the brackets for the function, you need to put the return statement. Okay, good. So, last but not least, in terms of importance, functions can be nested, and this will have a lot of consequences. So we can define a function inside another function. I mean, this is quite peculiar. Not many languages support it. So we have a function, and we decide that we need another function. We define it inside the code of the function. So this hypotenuse, okay, and we define another function, square x, which returns x times x, and it returns x times x because we didn't put the brackets. And then to compute the hypotenuse, you know, the theorem for the square triangle, you know, you do the square root of the square of a and b plus square of b. Okay? Well, that's simple. You just define a function inside another one, nothing special. I mean, we try to use the simplest syntax. It means the arrow function when you put things one inside the other, because it's easier to read. Okay, otherwise you never know in which function you are. Okay, but I mean, it's not wrong. I mean, the JavaScript parser supports everything, so it's just about who reads the code. Okay. The function inside the outside function, so the inner function, is scoped within the external function, and it doesn't exist. It cannot be called outside. Okay. I mean, it's defined here. That's a reference to this function. And this function, I mean, cannot be called outside, because square, it's a local variable of the function. And we say that the scope of the function is private, and also is not returned outside. And so once the function is finished at the execution, I cannot use square anymore. Okay? But inner functions, so square, can might access variables declared in the outside function. So something which is visible in the scope of the outside function. Okay? So indeed, we could use a and b in the function square. Okay? And this will have a lot of consequences. And namely, it will have the consequences of the fact that if you are able to return the reference to that function defined inside the other function, outside the function, that function will still see all the variables that was able to see inside the function. Okay? And this is called closure. We will spend a little bit of time on this, so don't worry. I mean, this is the formal definition. A closure is a name given to a feature, so it's a feature of JavaScript, by which a nested function executed after the execution of the outer function, so like square before that was inside, that function can still access the outer function scope, even if the code has already finished the execution of the outer scope. Okay? So let's see an example, because it's a bit difficult to understand like this. I agree. So actually, we say that each new function defines a scope for the variables that are declared inside that function. Okay? It's a private scope, and you can define variables as with other languages, no problem. But the point is that to those variables you can assign reference to functions, and those functions have a visibility about the variables that they see when they are defined. So it's what is called lexical scoping. It depends on how you wrote the code. You put the definition of the function at a certain point. At that point has a scope, okay, and has a visibility over a certain scope. So there are some variables which are visible to that function, and those variables will remain visible to that function. If you're able to use that function, those variables which are visible to the function will always remain visible, regardless of the point where you use that inner function. Okay? So it's like to say every function object remembers the scope where it is defined, even after the external function is no longer active. Okay, so that's basically what we called before closure. Let's have a look at the example. So that's a function that do greetings. So basically return a string saying hello somebody. Okay. In this function, we define another function. We could have done it with the arrow, but it doesn't matter. I mean, there's a function defined inside the greeter one that return hello plus something which is visible to this inner function, which is a variable outside the inner function, okay, which has no name. In this case, has no name because we have a reference to this function in this variable hello that we will return outside this function greeter. Okay, so that's how this function is structured. I know it looks like a very complicated example to show you just closure, but I mean it happens every time because basically you are more or less always inside the function, and you more or less always need to define a function to pass it to somebody, to some other function, or to use it for some purposes, and those functions basically create closures. Okay, and so for those functions there's a lot of things that remain visible even after the code has been executed. Okay, so let's see here the code. Const hello Tom, greeter Tom. What happens here? That in hello Tom we get what? A reference to a function, because that's the return value of greeter. And this function will be a function that returns hello plus the content of the variable my name, which when the function was defined was Tom. Okay? Const hello Jerry, greeter Jerry returns a new function. It's a different one. Okay, so we have two, let's say, hello functions, because we define two variables. We call the greeter 2 times, and we define two functions. And the other function, we return hello plus my name. And this my name, at the time the function was defined, contained Jerry. So when you call hello Tom, without parameters, because this function hello doesn't take parameters, you will get what? You will get hello Tom. And when you call hello Jerry, which is always greeter, it's always the function hello, you will get hello Jerry. Okay? Because the function that you returned remembers the value of the variable my name, even if this my name doesn't exist anymore, because it's out of scope of the function greeter, because the function greeter finishes its execution here at the semicolon, okay? Both in the first line and in the second line, okay? But the function inside has still access to the variable my name, okay, and to its value, which when it was defined, it was a certain value. In this case, was Tom for the first case and Jerry for the second, okay? So think a little bit about this. I know it's not so intuitive, but I mean, it's why you can always define and pass a function wherever you want in JavaScript, because when you run into a problem like this, JavaScript has a way to solve it. And the way to solve it is, we remember, JavaScript remembers the value of all the variables which are used in the function, in the inside function, that were visible when it was defined, okay? It's not about you that you need to destroy the content of the variables and so on. It's the JavaScript interpreter that takes care of all of this, okay? So there's a closure, that's fine. It will not destroy the content of the variable which are visible to some inner functions because they are in a closure, and unless this function, you lose all the reference to this function which has the closure, then they will be destroyed. But I mean, we don't really need to care about how the interpreter works. I mean, for us, the important thing is only that, these functions remember the values of all the variables which are visible to them, even if we use the functions outside where they were defined, okay? And this is just called closure, as we said, okay? Yeah, just, be careful. You shouldn't return hello with the brackets, because this calls the function. We are not returning the result of calling the function here. We are returning the reference to the function. If we put the brackets, it means we are executing the function. So basically, we are returning a string, and this example doesn't work anymore, okay? So this is all the explanation, okay? So each of the inner function remembers the reference to my name, even when the variable my name goes out of scope, okay? It's not destroyed by the JavaScript interpreter, because the JavaScript interpreter knows there's a reference to a function that has still visibility on that variable, okay? That's the explanation, but we don't really care about the explanation. We only need to understand the concept. Okay. So what we just created, well, that's a way to hide the values of variables from other code, okay? Because the only place where we can use and access the variable my name once we finish the execution of greeter is through this function that has access to that closure. So the variable my name is closed in this closure, okay? So basically, it's like it became private to that function, okay? So in a certain sense, it's like we created a private variable, because, it's not really private. It's that the fact that it's only accessible to the function that has access to the closure where it is contained now, okay? And this mechanism can be very useful. This is just an example, just for completeness. You are typically used to object-oriented programming languages where you define objects and you define private properties. because you want to manipulate those private properties only through the methods of the object. Okay? And this is just an example how you could implement this in JavaScript. I mean, we are not required to use this system in our coding later in the course, but just for completeness, let's finish the discussion here about the closures. So, function counter. Okay, so we create a private scope, the private scope of the function. We define a value which will not exist anymore at the end of the scope. Well, actually, that's not true, because if we define a function inside the other function that has access to value, it will still be accessible, but only to that function, to the function, the get next in this case. Okay? And of course, to be useful, this function needs to be made visible outside, and the way is just to return the function, the reference to the function. Okay? So in an example like this, it's like you create, actually, you emulate an object, because actually with counter here, you return not an object, but a function. Okay? Count1 is a function. Indeed, you can call it count1 with the rounded brackets. You call it once, twice, 3 times, and you get 1, 2, 3. Why? Because the function inside does value plus plus and then return the value. Okay? And the first time you created, you executed the counter, you got the reference to the get next, and the get next has visibility on a value which is 0. Okay, on value which is 0. And then you call it once, you do 0 plus plus, it becomes 1, and you return 1. Again and again, 2, 3, and so on. And if you create if you call it counter another time, you create another function, another closure, for get next. So there's 2 different get next. One get next has access to the closure that was created the first time you called the counter, and the other get next, which is contained in count2, has access to another closure that was created the second time you called the counter. So there are actually 2 different variable, let's say, named value in memory. The one that is inside the closure of the first call that you did to the function, and the other one that is in the second closure. Okay? And that's why you get, again, 1, 2, 3. Okay? And those 2 variables are isolated. So it's more or less like you have an actual object with private properties. Okay? And where you have methods, and you can operate on them. And you can extend the system. You remember that we can return more complex things from functions. So if we return an object that has 2 properties, which are actually 2 functions, we made an object, okay, where we have properties that can be used as functions, to operate on what's inside the scope of the function that we define, like this counter, so n, okay? So C counter, D counter creates 2 counters. It means it creates 2 variable n, which are still visible to the function that were returned inside the object of counter, okay? So one set of count reset has access to 1 n, and the other to the second n. Okay, and so you can use it like if it was an object with multiple methods and so on. So count, gives you the value and then increment by 1. So D count is 0, they are independent. C reset, and so C count is again 0, and D we didn't reset it, and so the next time we return 1, and so on. Okay, very simple counter. We did all this discussion because we might run also in some occasions where we might need to protect the scope of something. So make it inaccessible from outside. Okay, and so the way of doing it is defining a function, and to be able to use, I mean, what we do in the function. Well, the function, until it's called, is just a definition of a function. We need to call it, okay? And so we can simply define a function and call it, okay? Not these brackets. I mean the rounded brackets here and here are just outside the function to say that we put these two brackets to call this expression, which is actually a function. The previous expression is actually a function, so it can be called. And can be immediately called, just right after the definition. Okay? You know, JavaScript is full of these things. So we need to get used to this. Okay? And in case we need to have this value, or we need to have, you know, what is defined by this function, of course, I mean, calling this function, it means that if we return something, this immediately invoked function will have a value, and we can use this value as we like. Okay? Okay. So in short, we just need to define a single object. I mean, we can do it. We can use the previous code and just invoke it immediately here. We surround it with the rounded brackets, invoke it immediately. Of course, we will create only a single object because, I mean, we don't have another way of calling this function, which, by the way, doesn't even have a name. But I mean, the result is that we have n, which is hidden from all the rest of the code in our program, because it's now only accessible through the closure. And it means that it can only be accessed by through the count and reset function. Okay, and that's a way in which JavaScript can be used. I mean, I would say this way is typically used by libraries to prevent that you can access by chance some values that you are not supposed to change. Okay, but sometimes that might be convenient to use it. Depends on what we are doing. Okay, so last topic, and then I think we can answer questions and then maybe have a short break. Is constructor functions, and then we said everything we need to know about functions. Well, what's a constructor function? Well, I just say that we don't have you know, traditional objects in JavaScript. So why we have a constructor? Well, you know, I told you 10 days, and I mean, the result was this one. I mean, not very good. I mean, it evolved a little bit over time, but I mean, you know, that object-oriented programming is sometimes nice to have because it helps you to make the code easier to read, easier to write, and so on. So sometimes it's nice to have properties organized into an object where you can manipulate these properties through methods and so on. And also you can create an object in a traditional way, like you make an instance of a class. Okay? Since the class actually doesn't exist in JavaScript, I mean, the keyword will exist, but I mean, we are not going to see it in this course. But it's actually not really a template as in a traditional language, just you know, a keyword that was introduced to, you know, to simplify a way of writing objects. You know, what you can do with this constructor function is the fact that you can call a function using the new keyword before the name. Okay, so we define a function car, okay, with some properties, and in a traditional programming language this could be the constructor of an object. Okay, here we are defining a function, so there's no object at the moment. Okay, but it would be nice that we can sort of instantiate objects using a sort of template where we define properties in that object. Okay, and that's exactly what happens when you use this new calling a function, okay, that you defined previously in some ways, in the ways that we saw before. And you can pass parameters like you pass parameters to a normal constructor, okay? So what's the difference of calling a function with new with respect to just calling the function without the new? Well, if you call the function without the new, nothing happens here because there's no return value, okay? If you call this function with the new, it will return an object, okay? A new object, like you do with a new instance in the object-oriented programming fashion. And the new object is also already visible in the code of the function through the this keyword. So it looks more or less like traditional programming language, where object-oriented programming language, where you can initialize properties of an object. Okay, so the point is, here you could have written, open the curly bracket, make colon, make model, and so on. Okay, the result is the same. I mean, it's still an object, but you need to write it again to create another object. In this way, you have a more intuitive ways of creating objects which are similar, okay, with this keyword new, and you can pass the values simply as parameters of a function that we call constructor function, okay? So it's a sort of patch, we could say, to emulate what we do in object-oriented programming languages, even though it's not really an object-oriented programming languages with classes and templates, I mean, for classes. And so that's what we can do here. Just remember that if you use this syntax, it's very convenient to remember to put the initial capital letter. It's just a convention, but it helps you a lot when you read the code. If you see a function which has a capital letter in the beginning, you typically can call it with new, because it's a constructor function. So it means that inside the code, it uses this, and it will set some properties of the object that it will return when it's called with new. Okay? So just to remember this, remember to use the uppercase first letter, capital initial letter. Okay, I think if you have any questions, I'm glad to answer. Otherwise, we'll have, I think, 10 minutes break, something like this. And I prepare the example, okay, for the next hour and a half. So I will, in short, take the text of the exercises, which is already published on the GitHub, and we'll try to solve them together, okay, interactively. Okay, so see you in 10 minutes, something more. Thank you.